In the last video, we saw how we could use the maybe type to handle some errors for us. By returning nothing, we sidestep the problem of having an error that could crash our code. And in the case where everything works out perfectly, we can return just and whatever the value should have been. So that's certainly one way in which you could tackle an error in Haskell. Another way is what we're going to look at today, and that's using the either type. Either is similar to maybe in that it gives you options in what you can return. So let's have a wee look at the type of either in terminal here. You can see it's defined for a whole bunch of things. There's our old friend foldable there. But either, data either A and B, is either a left A or a right B. So depending on what happens, you can choose between a left value of type A and a right value of type B. Now this is certainly a little bit more flexible than maybe. Maybe is restricted to returning the type it started with. It's either going to be nothing or it's going to be just A, where A is the type you started with, so you can only return nothing in the other case. Here, we can return an entirely different type. Now this is quite powerful in that you don't necessarily just have to return an error message. You could choose to follow an entirely different path of computation in the case of an error. However, convention, usually when working with either for error handling, is that the right side is the correct side. That's the case where there's no errors, because right is right, essentially. Sounds similar, so we follow that convention. And that's the case. Left normally just returns an error message or carries out whatever happens in the case of an error. So let's have a wee look at how we would handle this function again using the either type class. Now, it's a little bit more complex in that when I say either up here, I have to give it two types. I have to give it the type that it should return if nothing goes wrong, and I have to choose another type to return if something does go wrong. But today I'm going to keep it simple and I'm just going to return a string. And here you can see not only can I return a string, I can return two lists here, because string is of course a list, and I can return a list in the other type. So it's quite flexible in the way that we can apply it. So now I need to say what happens when we have the empty list. And what I'm going to suggest is we return left. Remember, I need these constructors because that's how either is defined here. We have a left A or a right B, so that type constructor needs to go in front. That's the thing that wraps us around and allows us to handle the side effect in this way. So we're going to say just error, and that's sufficient. And then we say on the other hand, error as well. So that's fine. And now we need to define what happens when everything goes well. So here, just stick the constructor in front, right, and here we get right as well. So you can see here it's a little bit more flexible. So let's reload this. Oh, I misspelled right. Of course, nothing could go right in the first time. So let's reload again. And let's call func on the empty list. And here we get left error, left error. And of course, if we call this on func on 1 to 5, everything goes as we would expect. So this is something that can give you a bit more flexibility. A could be the result of the first value on the left side could be the result of some other computation. So for example, if you were writing a program, the left process could be the one that says incorrect input, please try again, that sort of thing, whereas right is the thing that carries on doing what you would expect to happen. Now, similar to last time, we can raise values to the either type. So let's say that I have a function called toEither. And let's say it starts with a B, and this is just to help me keep things in my head correctly. So we want to raise something of type B to either A, B. I'm just saying we start with a B here because the left side, if we're thinking in the world of error handling, the A value is the error value. And this isn't necessary, you don't have to do it this way, I'm just doing it to keep that in my head. So toEither, some value of x is equal to right x. Notice here I couldn't actually say left x. There's only one correct value that I can choose because B has to be on the right hand side because of the way I've declared the type up here. Now of course, if I save this, reload, and I go to type toEither 5, I'll get right 5. And of course this is polymorphic, so I could do mash some keys, and I can raise that as well. So I can now raise any type essentially to the either type if I'm so inclined. And of course, similar to last week, I can have an apply function. This was our last time where I said, okay, well, what happens if I have a function that goes from a to maybe, but I have a maybe value to start with? So let's see what happens here. So we have an either, an a, or a b. And then we have a function that goes from b to either a or c. So this is a function from a to c, or b to c, sorry, that might fail and return something of type a. So I'm just going to keep that type a as I go through. It could be a or c. So I should hopefully go from b to c. I'm just reserving a as that sort of error value. Again, that's not necessary. This could be a different type. This could be a different type. I'm just saying that for the sake of some consistency. And then I need to say what happens in the case where I have left x. I shall put some brackets around that. And some function. Then I just return left x. Notice again here I can't actually choose. There is only one correct thing for me to write because I don't have anything that maps from a to anything else. So if I get a value of a, there's nothing I can do with it other than return it. So this part of the pattern matching is essentially chosen for me. And now I need to do the other case where I have a right x and an f. And similarly, I can just say f of x. So I'm just pulling out the value because I know in this case it is not a failed value, it's a value I can work with, it's a value of type b, and then I'm applying the function. And the function results in an either AC, so that gets me out in the end there. So you can see here, either is a little bit more involved, it's a little bit more complicated, but it can offer more flexibility in how you tackle things. You're not just restricted to returning nothing. Of course, you could return nothing and then define a function that carries on computation in the case where nothing is returned. However, here you can just go straight into doing the computation. Another thing we can do, because this doesn't just have to be treated as an error type, this could be treated as just something that lets you choose from two options, similar to an if statement. So let's say we have a new if, and depending on a boolean, we're going to take a value of a, and we're going to take, let's say, a value from a to c, and we're going to take a value from a to b. Actually, we should have done this the other way around. Let's do that actually. Let's a to c and a to b, just to make a bit more sense. And we return either as a b or a c. Now in this case, you shouldn't think of this as being the b case being the error fail case. This is another case where we can do something else entirely. So we could say new if I have true and a value x, so function f which goes from a to b, and a function g which goes from a to c, then if it's true, let's say I default into the first case and I do the a to b route, and then I can say I'll return left f of x. And similarly, if I have false, then I should do the a to c route. And so for an x, an f, and a g, I should return right g of x. So you can see here I can use the either type for more things than just error handling. I can use this as something that will let me choose a path of computation. So in this instance, the fact that we can choose between different types is quite powerful. So let's save this, and I'll reload that and make sure that I've not put any errors in. So that's good. And let's say I want to just do true, and I take a value of 5. Let's just restrict the integers for the sake of example, and let's say that x equals to x times x, and the other function is just +1. It's the partial application there. Then hopefully this should default into the first case, so this should do left f of x, where f is x to x squared. So hopefully this should default and give us left 25. And indeed we get that. Now of course, if I replace this true with false, then I get right 6 because I'm just adding 1 to this 5 defaulted into the second function. Now these are just integer to integer functions. Of course these could be something entirely separate. You could choose 1 lets you choose between, say, running a stack application, and 2 leads me into some sort of file processing. So these could be entirely different routes that we follow. It's just that here I've restricted to simple values so that we can evaluate them quite quickly. So that's everything for today. All I want you to take away from today is we can also use the either type to handle errors for us. And the either is a bit more flexible than maybe. It allows us to return something maybe of some significance, or carry on doing something else entirely, whatever it might be. But either way, if you have any questions about anything I've covered here today, please do feel free to get in touch. Thanks.